Thanks, Jim. Appreciate the intro. Let me just introduce myself. As Jim mentioned, my name is Goutham Rao. I'm the co-founder and CEO here at NeuBird. I guess many of you guys in the audience, I am a developer, so I'm an engineer. I'm very hands-on, and I've also played the role of site reliability engineering. But we'll get into that in just a moment. I'm here more to talk about agentic systems and its growth in the enterprise today. Before all of that, let me give you a little bit of background on myself. I graduated from University of Pennsylvania. Went on to start my PhD, didn't really complete it. I have a background in my graduate education in building large-scale neural networks. And I also share a passion for data science, which is interestingly a combination of what we're doing here at NeuBird.ai. We are a Microsoft and a Mayfield portfolio company. We work very closely with the Microsoft research teams. We are very heavily deployed in both Microsoft Azure and AWS, and we have a growing footprint in Google Cloud as well. We are based here in Redwood City, California. We're about under 50 people. We have been in production at a wide variety of customer sites since late last year, Fortune 5,000 companies, all the way down to the small to medium-sized enterprises as well. We are available in both the Azure and the AWS marketplaces. I'll talk about our product toward the end. Really, the point behind my presentation here today is to talk about agentic systems in general. So, before I get into agentic systems, allow me to probably share a little bit of the obvious. How did Gen AI start making its inroads in the enterprise? I'm not talking about ChatGPT and everything that all of you guys know about Gen AI. Allow me to tell the story and how Gen AI is making its way into the enterprise today. It started, with the, the onset of ChatGPT, people adding chatbot type interfaces to existing enterprise applications. And then that led to more interesting applications where people wanted to interface their existing enterprise content with these large language models so they could have either a much richer experience against their internal knowledge bases, documents, various applications. And so this, we use what's called retrieval augmented generation for that, involving vector databases. And there are a number of different platforms that allow you to have a sensible conversation with enterprise content using retrieval augmented generation. We are now entering an era of something called agentic systems. And those are different from the first two options. Agentic systems are different from chatbots, and they're different from retrieval augmented generation. And I'm here to talk about why and how those are different. By the way, I know I have an hour. It's going to be hard for me to fill an hour's worth of content, so feel free to, we'll probably get more quickly to the question and answer section, Jim, so just keep that in mind. But back to the presentation, let me explain what it means to be an AI agent, because I'm sure all of you are hearing this term, everywhere. And so there's a lot of different opinions on what an agent is and how that differs from retrieval augmented generation. And in a nutshell, the primary engineering difference is the following. In retrieval augmented generation, you are providing the context to the LLM. You are in various ways, shapes, or forms. And so you have all of these knowledge bases and documents, and either explicitly or implicitly by way of a vector database, you are providing some content to the LLM to be able to read that, augment its training and its knowledge, and do a certain task for you, potentially explain what's in the content, answer questions about the content, or maybe create net new content by using that as reference material. That's not what we do with agentic systems. Agentic systems are more about extracting the reasoning capabilities that exist in the LLMs so that the LLMs can access the necessary context. Because typically in these systems, there is way too much information to dump into the LLM. Context windows are quite large, I get it, but more context sometimes you can get a lot of noise and garbage. And when you're building an agent, you have to be surgically very accurate, especially as it relates to what we do at NeuBird AI. We are creating a site reliability engineer, which means You can't be 70% in the ballpark of why my systems are failing, because then you're going to lead the engineer who's on call down the wrong path and cause even more trouble for them. You have to be very highly accurate. When you say I've diagnosed the issue, and you have to be 100% confident and accurate that you've identified the issue perfectly. And that involves context engineering and surgically extracting only the necessary context for the LLM to reason with. So just to recap, in building an agentic system, we don't necessarily dump content into the LLM like you would do with ChatGPT, where you would copy paste log lines and say what's wrong here. Instead, you're having the LLMs somehow, shape, or form interface with a wide array of various contexts. In our case, this is application and infrastructure telemetry. Somehow you allow the LLMs to come up with a thought process, something called a chain of thought reasoning. The reasoning then says, I need to extract this context and that context, and that really is what starts the foundation of an agentic system. This coupled with having a feedback loop. So typically you don't get to the answer in one shot. You allow the LLMs to extract the necessary context through a chain of thought, infer some decision, micro decision from that context, and then go back and extract some more context to keep doing this iteratively until it can conclude that it's getting closer to performing a task. So just to recap, chatbots, easy to understand, chatting with my applications. Retrieval augmented generation, I'm somehow, shape, or form providing some content and having the LLM do some work. Agentic systems iteratively create a chain of thought so that the reasoning can allow it to extract the needed context, and it's hunting and pecking and getting the right information to fulfill a job function. Now, when we're doing the reasoning in agentic systems, we use a variety of different techniques. We have LLMs argue with each other. We have LLMs cross-check each other's work. We evaluate the response of the LLMs against knowledge bases. An example, when we are working on an incident, maybe I am seeing an elevated number of DNS timeouts on my website. Well, any number of things could have happened. You have the agentic system start probing different layers in the stack and create a chain of thought. And when it comes up with a decision or an inference, well, the chances that you are running into this particular DNS timeout the first time on the planet that's not the case. It's probably happened before, and there are some reference cases around that exist somewhere, potentially even within the enterprise. And so you have the LLMs cross-check its response, and is it within the norm for this type of telemetry to have that sort of conclusion? And so all of this is to keep driving the level of accuracy so high that the mistakes that the agentic system makes are minuscule, and people are starting to trust it to do autonomous tasks, to, in our case, resolve issues. Various people are building different types of agentic systems. There are coding agents, there are DevOps agents. And so these agentic systems have to have a next level of accuracy if they're going to perform engineering functions. What we do at NeuBird AI is we build an SRE agent. So it is an agentic system, but it is even more focused on a very specific subset of context engineering. We work with IT telemetry, which are things like application and infrastructure logs, metrics, which is time series information, many times stored in databases like Prometheus. These are semi and unstructured documents like JSON documents, which quite honestly have some sort of structure associated with them, nested fields, arrays, lists. And so you have to be able to extract the right information from some rather very complex data structures. And then you have traces and distributed tracing, which are extremely difficult for people to parse, but LLMs do a really good job as long as you have the right context engineering. And then you have other tools using things like MCP, where you could have external context sitting in your Kubernetes cluster. A lot of times your teams may have custom CLIs that go in and fetch some information from a specific application that you would use as part of your debugging process. All of these provide context to the agentic system, and having a system that can interface with this context in such a way that it is able to sensibly make information across these different complex telemetry sources. That's the core thing that goes into building an enterprise agent. So I'll just say one thing here. In some cases, some people building agentic systems like to build their own models and fine tune them, and that may work, and that's fine. We at NeuBird AI believe that the foundational models, especially the ones from Anthropic, today we use a combination of Sonnet, we use some GPT models, we use Llama 4. We believe that these models have a lot of rich training in them already. They have an advanced degree of reasoning. These are agents that you would use with your Copilot or code. Our job is to retain that reasoning capabilities in those LLMs, but rather make them very effective by providing the best form of context engineering, being able to extract exactly the right context that is needed for the debug task that we're performing at hand. Why is that important for enterprise IT? And I mentioned some of this before. Enterprise data is extremely difficult to deal with. Data has always been the Achilles heel for the modern enterprise. There is too much data, and there is a lot of complexity in the data across the board for enterprise data. Forget IT data for a second. Salesforce information, or just information sitting in Jira, or information sitting about in your CRM database, or information about product inventory. A lot of these have complex data structures, and there's a lot of this information. So to be able to extract the right information that's needed for the specific incident or the task at hand is of utmost importance. I'll just call out three here. If you were to look at metrics, you have various types of metrics and operations you can perform on metrics. You have instant vectors, you have range vectors, you have counters, you have gauges. Each of these different metric parameter types have very specific meanings, very different meanings, and you need to be able to understand what each metric means. And believe it or not, in a very simple environment, it's not uncommon to see 40,000 different types of metrics. And that's even in a mid-scale environment, and things get even more complex. And then on the other end of the spectrum, if you look at traces, you can do point-in-time lookups, you can do time range searches, you can do latency distributions between service endpoints, and to be able to parse this data is also very difficult. And don't even get me started on logs and JSON. Every application developer out there has a very specific way in which they like to format their JSON logs. And to be able to infer and interpret the schema here and the schematic dependencies between a log line and its metric counterpart, or a metric counterpart and its trace dependency, this is very complex to do. But once this is done, your agentic system will have a very high degree of accuracy. So now coming a little bit more specific to what we do here at NeuBird AI, as I mentioned, we are building an SRE agent. Why are we doing this? Well, I told you that I'm a developer and I stand by my product, and I mean that. And I've built many different enterprise products in my career, throughout my career. I've been up at 2 a.m. debugging, going through log lines and debugging issues, many times issues that I have caused, so my bugs. And so I know how difficult it is to deal with these observability platforms out there. No ding on their part. These tools are fantastic. Datadog does a great job. Splunk does a really good job with log searches and semantic searches, and so does Elasticsearch, and you have Dynatrace. But the problem is, still, it takes a human being, a very tired human being many times, and many different people with different areas of expertise. There's a person that's a networking expert, and a storage expert, and a database expert. Everybody has to come together to solve what could potentially be a very simple issue. Takes hours, sometimes days. You're staring at dashboards, crafting very complex queries. And so there's a strong desire now for enterprises to move toward agentic systems. depending on how you believe various reports, there was one from a very popular analyst that was published mid this year. It was estimated that the global 2,000 companies last year in 2024 lost close to $400 billion in unplanned IT outages. You break that down, that's roughly around $200 million per enterprise. And we're talking about the large scale enterprises. I'm sure these numbers are much smaller for the small to medium sized enterprises, but this is not, you have these big issues, but hopefully they are few and far between. But anywhere from the long tail of issues like, why is my website slow? Why is my payment processing application not working? Why is the shopping cart feature on the website erroring out? So any number of these issues are unplanned IT issues where people have to get involved. That's what these systems are designed to solve, and hopefully allow the engineers to focus on more creative tasks. Engineers get into the profession to be creative, not necessarily to look at log lines and then grep and write awk scripts and then do the correlations, which can be done. Sometimes it's fun, but by the third and fourth time, it gets very tedious. And these agentic systems don't tire. They're able to do this quickly. You can talk to a VP of engineering or a site reliability engineering manager, and they'll tell you how many open tickets they have. And you could just ask them, over the past 6 months, how many tickets have you resolved? What is your mean time to incident resolution? And those numbers are typically very poor. Enterprises typically get graded very poorly on that. And all of this impacts the bottom line for the business, meaning what? If I fought a fire last week and I had an unplanned IT downtime because I pushed code into production, well, this week I'm going to be more careful. I'm going to go slower in taking changes. But that reduction in speed comes with a reduction in how fast you can push new product and functionality out to your customers. So these are not unrelated. Being able to improve your quality of IT operations and keeping the time to incident response down using Gen AI, it's a big thing. It's a very important thing for enterprises. There's a lot of interest in seeing how Gen AI can increase the bottom line, reduce churn. There's also, churn in the engineering ops teams because there's burnout. People have these things called alert fatigue. Every time you get an alert, you have to look at your phone, get online, look at what's going on, the paperwork associated with it, documenting what happened. These are very tedious and it's always stressful. There's a strong desire in enterprises not to subject their engineers to that kind of an environment, and agentic systems can move the needle a lot. How do I know this? We have our agent called Hawkeye. This is what's been used in production. We're one of the widely available agentic systems out there. We are the first agentic SRE to market. We've been working very closely with Amazon and Azure, Microsoft in particular, with all of their customers. Incidentally, Microsoft itself uses our agent internally and for their Azure Ops. We've learned a lot in building this product. We've learned in how to make our agent better, but we've also learned in how it makes our customers' lives easier. And so you can see some of the use cases here, all the way from automated ticket resolution to very fast root cause analysis, down to uncovering hidden costs. There's a very large company here in San Mateo that we work with, starts with an S, that focuses heavily on cost optimization for their cloud infrastructure. And so Hawkeye, on a automated basis, will constantly look at yesterday's baseline, and if it sees that today the cost is projected to drift more than 5% of yesterday's baseline, we'll quickly go in, run a root cause analysis, come up with a report saying we are using more capacity on our RDS servers, or somebody went in and rogue deployed a couple of EC2 instances, and can do all of this work very quickly on a routine basis. So there's a number of interesting use cases here. Happy to chat about them after my session. How does this work? So I talked a lot about, just to recap, what is an agentic system? How is it different from other Gen AI projects? I talked about what it takes to build a quality agentic system, and we talked about context engineering. But how does this get consumed? what's the proper way for deploying an agentic system in an enterprise? Well, we learned very quickly that a lot of times the weakest link in the chain can be a human being, meaning if you provide an agentic system to somebody that doesn't know how to use it, the quality of the output is only as good as what the person is asking the agentic system to do. We believe that a good way to introduce people to new technologies is to have the technology introduce itself and expose its capabilities and what it can do. So we believe in silent agentic resolution. Our agent deploys itself seamlessly into an existing stack without disrupting any of the enterprise's infrastructure environment. So no changes to your observability platform. We work with existing ITSM tools like PagerDuty, Atlassian, Jira, ServiceNow. We silently pick up tickets and issues as they're coming in. We are constantly sweeping the environment and looking for any deviation from the norm or any anomalies, and we go to work on our own. Engineers can interact with it, can ask Hawkeye to go in and run an investigation, or when Hawkeye detects an issue, a typical workflow would look like this. A PagerDuty alert gets fired saying that we're seeing a service degradation. Hawkeye will pick up that ticket, start looking at the right sources of telemetry, and will say, hey, for this ticket, for this application, I know where its logs are going, I know where its metrics are, and we'll start looking at the necessary logs, traces, metrics, and then start creating a chain of thought and silently resolve the issue. So the idea here is by the time the on-call engineer gets a page on their Slack or Microsoft Teams, Hawkeye would have immediately responded saying, I am looking at this issue, and a couple of minutes later, we'll post the root cause analysis report. The engineers can interact with it, can ask it follow-up questions. So how does all this work? Demo time. Let me switch to, when you onboard Hawkeye, the first thing you would do is you would add, and this is what a dashboard looks like, by the way. As a manager, if you log in, Hawkeye will tell you the good, bad, and ugly. It'll say, overall, your IT operations are at 80% capacity. Your databases are okay. We seem to have critical issues with our API gateway. You need to pay attention to that. And the user can drill in and say, why do you say that, and so on. But before you even get to that state, what you would do is give Hawkeye read-only access to your environment, your compute and infrastructure environment, which could be running in any of the public clouds. If you're running in AWS, just click on AWS, read-only ARN, ID, select the region, and you're up and running. Incidentally, Hawkeye deploys both as a SaaS and in the enterprise's VPC. So it's completely secure. There's no telemetry that ever leaves the customer's premise if they don't want to. Invariably, enterprises have more than one observability platform. We support every observability platform out there. So if you're running in AWS and you happen to use Datadog and Elastic, not a problem. Add your AWS connection, provide your Datadog API key and your Elasticsearch endpoint, and you're good to go. A lot of times people will use Grafana, and so you would simply come in and give your Grafana endpoint. If you're using GitHub, and you want Hawkeye to be able to do, hey, you checked in this code has this bug, and this is causing this breakage, not a problem. It can do that. Prometheus, obviously, we covered some of these things, but we support every observability platform out there, and this is important because in a full stack IT environment, on average, people are using at least 6 or 7 different observability sources. So not all of your telemetry live within one observability platform because that's just how things grow organically. Sometimes there's a cost element to it, so people will have a cost reaction to putting everything in, say, a Datadog, and so they'll spread the load out. A lot of times people will just have logs sitting directly in S3, very cheap option. You guys get the gist. But once that's done, this is what your environment looks like. Hawkeye is working asynchronously behind the scenes. You can see here there are issues that are coming in on a routine basis. This is one of our demo test environments, but you'll see here that an issue came in a minute ago. There was another one an hour ago, 2 hours ago, and Hawkeye is silently picking these issues up. And I'll walk you through how it does it. But first, it does incident historical correlation. It will say, has this issue ever happened before? And if so, what did we do then? A lot of times you'll get multiple alerts at the same time due to the same issue. And we do something called incident deduplication or issue deduplication. And we'll treat all of them as if they're related, if they are, and investigate them as such. If you want to look at what an issue looks like, this is what the on-call engineer would see. I see that there are, I don't know what this is, pod number of container restarts is greater than whatever threshold. Hawkeye went in and saw, why is that pod restarting so many times? The user can look at the root cause. And this is what a root cause report looks like. This will be available on the customer's communication tool of choice, email, Slack, Teams, or sometimes directly in Jira itself or in PagerDuty. If they click on the link, they have an interactive dashboard. It'll give them the incident description. It is very transparent and self-explanatory. It'll cite the timeline of events. It will give you the evidence as to how it came up with that and the root cause and the corrective actions. Like you guys, I'm an engineer, so I'm skeptical. I want to see how Hawkeye came up with this chain of thought. I can click on Run Book Findings, and here it will tell me how it methodically broke the problem down into, in this case, 4 chains of thoughts. Sometimes it could be 2, sometimes it could be 6. This is where we're letting Gen AI do the magic that it does. It will start creating a flight plan. It will tap into various sources. Here it's looking at logs. It looked at more logs, looked at some metrics, and created a intermediate conclusion and decided it was headed in the right direction, but didn't really have all the information it needed, and then created yet another chain of thought based on this, went back, did some more digging, found some more information, and it keeps doing this until it is always cross-checking itself and saying, am I converging toward an answer? As it got closer to the answer, it says, okay, I'm good. I'll create a root cause report, and creates the final report. If the user wants to interact with it, there is an interface. I can go in and I could say, I'll just copy this. I can say, what is the current health of? And as the engineer could fire that off, and Hawkeye will go in, create a new flight plan, and you can see here that it is went back into investigating state. It is preparing a baseline, and we'll come back to this in a couple of minutes, but these are not instantaneous, folks, because it has to probe multiple sources of telemetry and run some rather complex calculations. It is looking at logs, metrics, traces, and cross-checking itself. And when it feels comfortable, and in about 20 or 30 seconds, it'll start coming back with an answer. But what it does is it creates an investigation plan. So it says, to answer this question, I'm going to look at the environment. It does some baseline analysis, looks at different sources, probes the telemetry, and starts creating the computations and the results. And so you'll see here that while it's doing that, it's coming back with the results. And it'll also tell you ahead of time, based on the results that it's seeing, what it plans to do next. So now it's creating a summary of what it found, and this is for the end user consumption. And that's what it found. So like this, I could keep interacting with Hawkeye and keep asking it questions. You could ask it to look at different sources, probe different environments. And so it is very interactive, but mostly people just have this on autopilot, and it's auto-responding to issues. So with that, I'll start winding this down, and we can open it up for questions and answers. What we saw there was how Hawkeye, or an agentic system, in our case, when it's responding to an issue, will reference historical data, establish a baseline, do some incident correlation and deduplication, and really the meat is using the LLMs to do the remediation, and that's where the context engineering comes in. And then it can try and predict to see if that problem will happen again, if the issue is creeping back up, alert the user saying, we fought this fire yesterday, we're likely to have the same trend again today, and so on. Last few things here. over the past 18 or so months that we've been in production, we've been able to demonstrate across a number of different customer environments of close to 90% reduction in mean time to incident response, reduce how much it's been costing these companies, how long it takes for them to fight an issue. We're deployed at a wide array of different customers. On the smaller end, this is a small team. The whole team is about 30 people big. They play the role of both engineering, and the engineers are on-call support too. And anytime they have to be on-call support, they're really not working on their engineering tasks. And for them, Hawkeye was a blessing because now they can focus on what they really like doing, which is building better product. This is a quote from their CTO on how critical issues have been solved by Hawkeye, and used to take them days. And that's days coming away from the core product that they're building, to a very large bank that has been able to save over $200 hours per month on a monthly basis, to a large hardware enterprise IT storage company here in the Bay Area. So that is it. The last thing I'll say here is we believe in a multi-agent world. There are multiple people building agents out there. We coexist with other agents. There are other agents that are designed to integrate with Hawkeye. We have, if you go to our website, you'll see inter-agent workflows where Hawkeye detects an issue, opens a pull request for a coding agent to go in and patch the issue based on Hawkeye's findings and root cause analysis. Jim, with
all
that.
Right. The speed run through SRE and how NeuBird is approaching building SRE agents, or an agentic SRE environment or platform. We've got a couple questions in the chat. I'll read those out loud, so they'll be on the recording. The first two seem like they might come maybe a similar flavor. One from Kranti. The LLM used by Hawkeye, are they kind of self-hosted on Llama models, or are they a public LLM? Do I need to make an API call out to Claude or ChatGPT? How does it work? I'm assuming the answer is going to be there's a lot of different ways we can do it, but
yeah, go ahead. We have our own default squad of LLMs. We prefer which LLMs should be used because we have fine-tuned for it. However, the customer is free to bring their own Anthropic key or our Bedrock key or OpenAI key, and we'll leverage those. Our larger enterprise customers prefer that model where they're hosting the LLMs and it's running in their account. And the SaaS companies really don't care, and we will run the LLMs. We use Anthropic and Bedrock and OpenAI behind the scenes, and we bill the LLM cost back to the customer.
Okay. And I guess the second one may be the same, but I'll just read it. Is Hawkeye using a cloud API provider, or did you train a set of frontier models to create this solution? Sounds like you didn't create your own model, but are just leveraging the existing models.
Right. We are a big believer in foundational models, and the people building them are doing a fantastic job, and keeping ahead of, and especially Anthropic is sort of the leader in the coding space, and we leverage a lot of its reasoning capabilities. Our job on this planet is to reduce the noise and do the right context engineering so we can do the root cause analysis.
All right. And then Karanthi has another question on the runbooks. So the runbooks used by Hawkeye, are they defined by the customer, or is there something out of the box that is provided to help people?
Great question. We have our own runbooks, but they are modifiable and tweakable by the customer. The customer can go in and edit and augment the runbooks. We have carefully curated these for a number of different enterprise IT scenarios. That's the background we come from. We've seen every kind of possible application and infrastructure environment out there. That and the runbooks coupled with the reasoning capabilities and these foundational models do a fantastic job. However, there's always some tribal knowledge for an enterprise customer. For instance, Acme cluster is known to go down every Friday or almost every Friday because we push buggy code to it, or we're a little loosey-goosey in moving code to it. Well, that's very specific to you, that customer, and they can augment the runbooks with that information. You can do it in natural language form. We've seen people upload images of their infrastructure stack, Visio diagrams, architecture diagrams, dump all of that in. The more knowledge, the better.
All right, that's great. So we start out with some well-known templates, but easily customizable for the exact situation that you find yourselves in.
Yep.
All right, question from Kenny Kahn, one of our organizers here, and asking about, does NeuBird do anything in the post-mortem automation space? Maybe scribing or templating. So we've had a problem, we've solved it, now we need to publish internally,
100%.
maybe externally.
Great question. A common use case that we've seen a pattern is the following. When first people onboard Hawkeye, what they do is, before letting it go in and respond to new issues, they'll just say, go do an analysis of my previous issues and tell me how we've done. An example, a lot of times what do engineers do when they're under the gun? They'll do what I do, reboot. So I rebooted the cluster to get out of this problem, but we really don't know what caused the problem in the first place. Then they'll ask Hawkeye, the problem doesn't exist anymore, but last night we rebooted the cluster. Can you go back and retrospectively look at the logs and do a retrospective root cause analysis and what actually happened and how do I prevent it?
All right. DJ has a question. Is there an efficacy metric that you use to measure Hawkeye's success or failures?
Yes, we run something called evaluations under the hood. Luckily for us, we're not venturing into an unknown domain, like creating a new medicine or something like this. So we have rich knowledge bases of different type of scenarios and root cause analysis reports. So when we're generating that, we're able to measure the current analysis against a similar thing that would have happened in the past and what the accuracy rate appears to be, and that's called an evaluation. And when that reaches a certain percentage threshold, that's when we know that our analysis seems to be about right.
Does Hawkeye solve cloud microservices networking issues? Lots of microservices, maybe they're on Kubernetes, maybe some are on a serverless platform.
Guys, let me say this. Agentic systems are new. I'm not here to say that we've solved every IT problem on the planet. If that were the case, I'd be on a beach. It does a really, really good job. We've been told that in cases where it hasn't nailed the problem, it got very close and saved people a lot of time. And there's a human in the loop who will take it the last mile. It at minimum will get to 70 to 80% of the way there for the hardest of problems. For the most of the problems, it's just solving them on a routine basis. But if you have a very complex microservice-based architecture with dependencies on third-party API services, we had an issue where a customer uses us in a complex microservice environment and relies on Cloudflare. And in April or so, there was a major Cloudflare outage, and Hawkeye was able to detect it and determine it. Went as far as saying it looks like Cloudflare is a problem. Couldn't really say what exactly the rest of the issue was because it didn't have visibility into that. But so it saved people so much time in saying, hey, the problem isn't on our end, it's an external third-party service, and they can focus on that.
All right, yeah. So DJ says thank you for that answer. So say I'm a brand new NeuBird customer. Day zero, I set everything up, set up all the credentials, all the take advantage of all the built-in integrations to wire NeuBird up. Well, how much time does it take to bring the data in to start providing value? What have you seen?
So a great question. First of all, we're not ingesting any data. We do fingerprint the environment to scan some metadata and make some decisions about what your environment looks like. Are you running Kubernetes? Are you running databases? What services dependent on what other service? Sometimes your traces contain that information, but very few people have tracing deployed. So we'll infer that by looking at the logs. This metadata, very minuscule, stored back into your Mongo, a database that we're running for you in your environment. Again, if it's SaaS, it's just a document DB service that we're running. All in all, it's up and running within a couple of minutes. So it's not how long. As soon as you connect Hawkeye up, you will start seeing it scan your environment and look at all the issues within a couple of minutes. The dashboard will fill up. Now, to answer your question, like how do I know how well it's doing? Typically, we find customers within a day, they'll be able to benchmark and look at a couple of root cause analysis reports and tell us, hey, this is kind of doing really good here. Over here, kind of missed something. How do I tweak the runbook to do a better job? That's usually a day 2 exercise. So in minutes to get it up and running, in hours to get an initial assessment, maybe a day or 2 to get really comfortable with it.
Okay, so what I'm hearing is that if I had, say, I had an incident a month ago, but now just today I install NeuBird, as long as my data sources have that month ago data still, that I can ask it and it'll go take a look at it.
Everything within your retention period is good to go.
Nice. All right, another question from Kranti. Pop-up is covering up the question. Sorry about that. The database of issues or knowledge base mentioned earlier is that a RAG database which Hawkeye comes with out of the box? Or
yes, a database of known issues and sample reports is stored in a vector database and consulted. But that is only consulted as part of the self-evaluation. The actual reasoning and the current investigation is all being done through the reasoning in the models and your current telemetry, the state of whatever is in your current metrics, alerts, logs, traces. That's the live root cause. And when the root cause is done, it just cross-checks itself to say, for this kind of issue, for this kind of environment, is this generally in the norm of what would have happened?
And you're just curious about the RAG database technology, or what database you might be using behind the scenes to store that?
That's a good question. I think we're using Chroma currently for that, and it's just there's, believe it or not, there's not terabytes of content in there. It's just very highly curated. Again, we believe in high accuracy, less noise. More content isn't necessarily better.
All right, and if you don't mind, is it possible to dig a little deeper into the agent, how it's implemented? Maybe Google ADK or LangChain or custom?
No, so I unfortunately don't have slides on that, and I think we talk a little bit about it on our website. We built a language called Rail, which stands for, long story short, Raven AI Expression Language, which is a specific language that is designed to force the LLMs to create programs for us in a language that has a very strict grammar. So we define the grammar. So think of it like having the LLMs create a program for you. So we give it the grammar and we tell the LLMs, I'm debugging this problem using this grammar, write me a piece of code, and the code can call out to us to go in and sample different sources of telemetry in a very specific language. And this coding language allows us to do things like complex extraction of keyword variables using regular expressions, using push downs, and we're pushing everything down to the telemetry source. Now I'm getting into the weeds, but there's other things that allows us to do correlations. So think of it like saying, if I found log lines in my logging database in this time window, I want to do a join of it with a metrics database where latencies are greater than this threshold. So it allows us to do these kind of very complex joins, which is what you as an engineer would do when you're debugging a problem. If you're looking at a dashboard, you're visually and mentally doing very complex extractions and joins. So this language allows us to do that. And so no, to answer your question, LangChain wasn't suitable for this. Not that it has awesome uses for what it needs to do, but we needed this telemetry specific language.
Is the Rail open source? Can we look at it, or just as part of your IP and keeping it tight?
Yeah, it's not open source. Not that I'm against it. I'm a big fan of doing those things. It's just that where we are as a company, we are running so fast with getting these enterprise accounts onboarded. At some point we will. I just need some breathing room. Yeah,
for sure. Okay, I think we covered the AI models and frameworks already. So Adham, it's any of the models, not any of the models, but the bedrocks the OpenAIs. I didn't hear Gemini.
We do support Gemini as well, especially when running in Google Cloud. There's a strong preference for people to use Gemini. So yes.
Yeah. Okay, perfect. DJ says the coding language sounds like Gherkin, but specialized for DevOps.
Probably. I've heard others say that too. I'm personally not hands-on familiar with Gherkin, but I definitely have heard that.
I don't know if Gherkin is a big or a small pickle, but I have not looked at Gherkin at all. A cucumber, a big or a small cucumber, not a pickle. All right, thanks, DJ, for the question. I've seen a few other tools that say that they're in the SRE AI space, like Flip AI.
Yeah.
And Harness, the platform engineering company, has added Agentic SRE to their platform. But they both seem to kick in like when there's an incident, then now I use this tool. For NeuBird, it looks like it's just doing work all the time and it brings stuff to my attention that I should take a look at.
Both. Three trigger modes. A person interacting with Hawkeye and asking it to go do some work. It can also work in automated incident mode, where it will pick up an issue. It's been a while since I looked at Flip AI, and yes, there are at least 5 or 6 that I know of that are in this space. We obviously like to believe that we have, beginner's advantage, and we're way far ahead, and we've won against some of these guys in a number of different bake-off environments. But to answer the person that asked this question, the automated incident response mode, where it picks up the issue and goes to work. And over there, we find that people like to tune Hawkeye so it's not doing unnecessary work, and they'll focus it and say, if you're seeing issues that have these keywords, ignore them. Or if you see issues that have this word, make that a priority and focus on them. And there's a number of different instructions you can give Hawkeye on what to do. And also, you can set it up to do sweeps. It will do anomaly detection on its own. People find this very useful because a lot of times they'll be like, oh, I didn't know that. I didn't know this. And, because you can't plan for everything, especially in a very agile DevOps environment. Engineers are rightfully so making a lot of changes all the time. So you have not set up alerts for everything. You could not possibly have planned for setting up your alerting for everything. So it'll detect those.
Okay, yeah. So that lots of different modes of interacting. I can just ask it a question. I can use it during an incident. One feature on the Harness SRE agent that I saw was kind of interesting. I don't know if it's something that NeuBird does or if it even needs to do. But you can add your Slack and your voice channel for your war room that you have going on for an incident. It'll listen and try and help you figure out what's going on live from what people are saying and what it's seeing in the background.
Yep.
Is there something similar on
Hawkeye does that too. We have native Slack and Teams integration, and Hawkeye can also create an incident channel in a war room too, and solicit the right people to join. And it does this because for the current incident, it will go back and look at from previous tickets. If there was somebody that had worked on something like that, you can have Hawkeye ping them and say, "There's this issue. I'm working on it. You may be interested in watching this." And it'll keep all its updates over there.
All right, this is a joke, but does it always call the network guys first? Because the network's always the problem. All right, now a serious question from Pedro. While doing the presentation, I saw this could integrate with ServiceNow. Can this be integrated to create changes based on interaction with the requester and have the LLM trained with our past successful and failed changes? Is it doable with NeuBird? So
we limit how much proactive changes Hawkeye can do. We allow it to write back to ServiceNow with its findings and provide its recommended remediation steps. The same thing for PagerDuty, but there's always a human in the loop that has to approve the final change and take action. Not to say that we won't do that on our own. I know some customers are allowing Hawkeye to take actions, especially where feature flags are involved. So turning a feature flag on and off seems to be sort of an accepted operation that's very low risk. So people allow Hawkeye to do that. But as it relates to doing a kubectl apply and changing a pod spec, we will provide the recommendation, but we're not allowing it to take that action.
All right. So Kranti says, yeah, cool features, cool product. Thanks for the demo and presentation. I have a non-technical question that I like to ask all of our presenters. Sometimes we get a big mix of very experienced people on, some younger people, and it's a career question. So we're all, not all of us, but you and I are seasoned in the technology space. If we were trying to give
is that your way of saying that I'm old?
Yeah, I mean, yeah, you could say not necessarily, just experienced. But yeah, is there any advice you'd give to maybe an old person to continue the rest of their career, or a young person? Some advice that you've picked up over the years or learned through the hard knocks of building a business that you.
I don't know, Jim. That's a hard. Look, I like to think that as every day goes on, I'm just a little bit better than yesterday. So all that to say that I think my best years are ahead of me. So because I look at myself and I look at and I say, geez, you did that a couple of years ago. What were you thinking? So that happens on a daily basis for me still. But I don't really have any. I really don't like giving advice because every advice I've given myself, I've had to learn from it, and I'm like, I wouldn't really give that advice exactly that way again to my own self. The only thing that keeps me, going, if that was your question, is I enjoy doing what I'm doing. Like, I really am passionate about data science. I think at the beginning of this call, I mentioned that it's an interesting thing to be passionate about, right? Looking at data and analyzing data and making sense of data is a peculiar hobby, but I like it. I do that, measuring metrics with everything, just sleep data, or just in any aspect of life, right? So that worked out for me here. I don't know that others, if they're doing something, just as long as you find something that you really enjoy doing, then you're going to do a really good job at it. So that's I've been fortunate enough for that over here. And the only other advice, if I had to give, is if you're working on something and you think it's a cool idea, and you're in a competitive space, be very paranoid, because there are easily a handful of people also doing the same thing. So you just have to run fast and work very hard. Working very hard is super key.
No, that's great. And while you're talking, somehow I had flashbacks to looking through source code, trying to figure out who created this bug in the system. And the GitHub says it was me.
That's now I still write code here, and I join the engineering huddles whenever I can. And sometimes when I am not working on go to market and working with the sales guys, I'll just write some code, and in the huddle they're reviewing bugs, and they call out everybody that caused a bug, except when it comes to me, and I know it's me, because they're just our engineering manager will say, I wonder who caused this, and people are just looking down or at their computer or at their phone, and I'm like, what did I do now?
Yeah, DJ gives you thanks for the time. He's just wondering what time it is where you're at. I guess there's still sunshine.
I'm in California, so it is 3:30, and I'm soon going to get kicked out of this room. So I was wondering maybe I could switch to audio if that happens. But yeah. We're based in Redwood City, beautiful Redwood City. If you guys can see downtown.
Nice. Looks like a place to visit.
It is, yeah. It's a nice city. It's kind of halfway in between, right in the peninsula, about a 20-minute, maybe 25-minute commute to San Francisco by Caltrain.
All right. Yeah, if you do get kicked off, yeah, just go to audio. Maybe one final question before we close out this section, and then go to the optional second part of our.
Yeah, I'll join that second part too. I'll switch to audio when I do that. So I may drop and rejoin if that's okay with you, Jim. But
yeah, that definitely works. I'll make everybody a presenter. It just Adam has a question on any big mistakes that you ran into early on, and he's looking for things to maybe avoid redoing in his own career.
I appreciate that question. When when in our first company that I did, we started that in '99. There was a big mistake we did in choosing a market that was very volatile, and this was when the .com, or the bubble happened. Long story short, it was in the both the mobile and the IP telephony space, and the mistake there was betting on a very unproven but super hyped up environment. I don't think I've made a big mistake like that since, and we rectified. And the reason is because I am a big believer in, if you make a mistake, acknowledge it and change very quickly. But the degree of pivot was a little bit larger than I appreciated. But as a person, I've always been a big fan of fail fast. So and be ready to micro pivot. And so we make mistakes all the time. I make mistakes on a daily basis. We've made small mistakes here and there through my previous company, Portworx, and the company before that, Ocarina. Certainly, even maybe here at NeuBird here and there. But the idea here is measure what you're doing very quickly identify if it's a mistake, and you catch it quickly and adjust very, very finely. The longer you go between your implementation point to extracting the proof point, the more risk you have, and the more you're going to have to pivot. The shortest path between A and B in this case is not going to be a straight line.
No, thanks for that. So Goutham, we're going to close out this section of our event. Really glad you could spend your time with us, talking to us about not just the future, but what's available now. And look forward to having you in the next part for our networking event. So yeah. I'll put up a 5-minute timer. Everybody that wants to stick around, take a bio break, grab some water. I'll make everybody a presenter so you can share your camera and mics, and we can do a little bit of networking.
And I'll see everybody in 5 minutes. I'm going to grab a glass of water, switch to audio, and I'll see you on that.
All right. Thank you again.
Bye.
Appreciate it.